right, Cal, thank you very much for the introduction. Hello, everyone. I'm going to go ahead and I think I'm the presenter now. I'll go ahead and share my screen here. There we go. Should be sharing my presentation. Just confirm that.
Yes, it looks good, Justin.
Taking up your full screen? Okay.
Yeah.
So this will be a little less dense than the last seminar I gave, if anyone saw that before. But more focused on some specific issues of concern in the area. And before I dive in, Cal already introduced me, but I do want to point out, for those of you who might not be as familiar with EOS, I wanted to thank Cal Dutta and Amanda Marlin, who have put this together. Amanda's director of EOS, and for those of you who don't already participate and contribute with them, I wanted to give a plug for them. And I promise I was not asked to do this or told to do this. This is something I do out of my own heart because I think EOS is wonderful. And if you're viewing this online and maybe not local, it's great to know about one of our wonderful institutions here in the Tantramar area. So, and if you don't know, EOS is helping you restore local ecosystems, and they are monitoring local water quality in lakes and streams. They provide advice and support and evaluations for making your home more sustainable. And they do wonderful things like this seminar to help educate you. So please go ahead and show your support for them in any way you can in volunteering. They're a wonderful local organization, which is why I'm happy to give my time and help them out whenever I can. Okay. And it is my slide showing here, not my video of me, right?
Yes, it is.
Okay, cool. It just didn't look like that on my sorry. And as mentioned earlier, I've done another one of these groundwater webinars. I did one last year in October, and that's available on YouTube. If you go to the EOS Eco Energy account, or if you just search for my name in groundwater, you'll probably find it. But that one gives more of a background primer on groundwater. So if there's some basic questions you have, or some things that are, that come up as we're talking about some of these issues, please feel free to ask them, but also know that this is a great resource there that's available. That's more of me kind of giving a very light lecture on groundwater basics to understand how groundwater moves, how it flows across our landscapes, how it recharges, and a little bit of the basic information about it. So just know that that resource is there. I also want to give you a little bit about me. This is also a way of, saying who I am. I feel like every time you speak publicly as a scientist, you should be saying like what your actual expertise are. And I should note that my expertise is not necessarily in groundwater. I have studied groundwater. Mainly in the way I've studied it is in what nutrients it carries to coastlines and how that affects the life on coastlines. My main research interest in what I do here at Mount A, in my teaching and in my research, focuses on microbes and what happens in the cells of microbes, how they grow, their physiology. But I'm also interested in how that in turn affects coastal ecosystems, and also how it affects what we call biogeochemistry, the cycling of chemicals and nutrients on the large scale, both regionally and globally. So things like how carbon is cycled across the ecosystem, going from the air into plants and then being recycled. That's what we mean by biogeochemistry. So my main interest is basically how chemicals move through the landscape and through coastal ecosystems, particularly through microbes. But that has allowed me to do a lot of work in the past that deals with groundwater. And now I teach courses at Mount A, particularly one in ecotoxicology, where I've had to do a lot of reading and thinking about the things I talk about here to help educate my students on current issues about groundwater contamination, things like that. Okay. So I did show this slide in my last talk, but it's worth giving a quick overview of what we're actually talking about here, of why we should actually care about groundwater. First, it's important to define what it is. Many people think about groundwater as sometimes as like underwater caves or of like a pocket of standing water underground, and that is generally not what we're talking about. Groundwater just simply refers to the water that's held underground in soil or small spaces in rock. So when we get to a level below ground where the soil or whatever is there is so saturated that we have all that space essentially filled with water, and there's enough water pressure that would actually be able to fill a pipe that we put into it, that depth, that's when we're talking about we're at the level of groundwater. It should be noted that we're talking about 98% of the Earth's available fresh water. The vast majority of the fresh water on our planet that is accessible to us in one way or another is actually underground, not what we see on the surface. And it's also very important for us, both for life and industry and countless other reasons, particularly here in Canada, where about a third of our drinking water comes directly from groundwater rather than surface water sources. And in particular in New Brunswick, about 40% of the New Brunswick population relies on drilled, dug, or spring-fed groundwater wells. So we have quite a bit of reliance on groundwater in our province in particular. And it should be noted that when we talk about drinking water supplies globally or within Canada, this is a primarily rural emphasis on where people are relying on groundwater for their drinking water. So New Brunswick's a rural place. You shouldn't be surprised that a lot of people are relying on groundwater. And also, it's important to remember, and this is what a lot of what I talked about in the last seminar, if you're interested in this, is how groundwater moves. It's important for us to remember that it's not something that just sits underground, but that it moves. It moves downhill, essentially. It moves depending on what types of aquifers or which locations of groundwater we have stacked between layers where water can't pass underground. It moves from land to the ocean, so it carries things to the ocean just like lakes and rivers do. And it brings its contaminants that might be in there along with it out to the ocean. But also we have some transport in the other direction, as we'll talk about more later in this talk. So of pressure from the oceans kind of feeding back and influencing our groundwater. So there's a lot of different local issues that we could talk about in terms of, sorry, turn off this noise out here. There's a lot of different local groundwater issues we could think about. When I first started doing this seminar, when I did one last year, and when I thought about this year, I immediately started looking at papers and lists and trying not to just trust on things that I know and I assume, and instead look at, okay, what are the actual things that are listed as the greatest threats to groundwater, either here locally or more broadly in any kind of rural area. And there's a lot of different things that can come up. So there's a lot of different things that we could choose to talk about. And there might be a lot of different things that you might be interested in or you have questions about that are not on this list. So I'm just trying to acknowledge that first off, that there are a lot of different things that we could potentially talk about. And here's some of the things that I talked about last time when I mentioned briefly some issues at the end. For example, things like nutrient pollution. So this is just excess nutrients, fertilizer from farms, sewage running off into our surface waters and eventually or percolating down into our groundwaters. And then when they come back to surface waters or when they go into drinking water sources, they can cause problems like creating noxious, harmful algal blooms in lakes, or some of those nutrients themselves can be poisonous to humans when they're in such high levels like nitrate. Or they might be carrying E. coli or other bacteria that might make people sick, either because they came from sewage or they came from farms that have a lot of manure on them. We also have issues like saltwater intrusion. Sorry if I doubled my text there. Saltwater intrusion, I mentioned this a little bit last time. We'll talk about it more this time in terms of what the actual risks and prospects are. But this is of the process where we have seawater essentially mixing with our groundwater and pushing its way into our freshwater groundwater sources in some way or another. And it should be noted that this happens because of sea level rise or because of drawing from water and sea level, drawing from our local freshwater groundwater and allowing seawater to move in. But it also can happen for natural reasons things not related to sea level rise or climate change, inland or away from the coast, where there might be deposits of salts or deposits of briny water underground. And that does happen in New Brunswick. But what we're talking about here is, in fact, the intrusion of salt water into groundwater that happens on coastlines, and it's becoming more of a problem due to climate change and sea level rise. So there's other issues that got brought up last time when I asked the people in attendance, okay, what things do you think about that you're interested in? And these are some of the things that came up, and we did talk about it. We also talked about groundwater management on farms, issues like tiling, how we control the water level on fields, because that can take water from other places locally. People asked questions about quarrying or fracking. And I just wanted to note some other issues that came up, or some other things in discussions, or me looking at lists of things that should be of concern for any kind of rural area for groundwater. Some other issues that have come up that people asked about are forest fires, the effect that the recent fires we've had locally and more broadly in Canada, how that could affect groundwater and water quality. Things like forever chemicals, you may have seen that in a lot of headlines if you follow any environmental news. Technically, they're what we call PFAS, per and polyfluoroalkyl substances. But that's something that is of great concern for many people around the world in contaminating drinking water. Fuel waste is actually a major kind of source of groundwater contamination that people don't often think about. There was a recent report by the CBC showing that there's about 1,400 sites within New Brunswick that were deemed as contaminated that have not been treated, just basically due to the fact that there's a lot of them and it takes time to get to them and there's limited resources to deal with them. And I think something like 40% of those contaminated sites were contaminated because of fuel waste. So some kind of oil or fuel, gasoline leaking from either a residential or an old industrial site. Pardon me, let me quiet down my hallway. So it's actually a major source of groundwater contamination in our province that often goes unnoticed, and it can be kind of hyper-local. Another one is arsenic and manganese, which has come up recently. I don't feel like I have the resources to talk about that one as much as I'd like to here today, but that's definitely one that I would like to address and talk about more in a follow-up seminar. But I'd also be happy to take any questions people have about that. What I plan to focus on today, as implied by the title, was sea level rise and forest fires. So those are the two issues that we can concentrate on today. Again, we're talking about sea level rise and how it affects groundwater. We're talking about saltwater intrusion of the seas coming in and pushing their way into our groundwater resources on the coastline. But another issue that a lot of people don't think about is that if the sea level pushes in and pushes our groundwater up or across the landscape, if it runs into some pile of contaminants underground, it's going to pick those up in that groundwater and carry them along with it as well. So that's another risk that I'll explain later. And then, of course, with forest fires, they can have large effects on how water moves on the landscape. They're going to affect how water can percolate into the soil. They're going to affect how water is filtered and trapped by forest. The forest is no longer there. But more importantly, what a lot of people are concerned about, and you may hear about with recent fires, is that the ash and the soot, natural byproducts of the fire, but also the waste that comes from the fire of burning residential locations and businesses, and all the huge variety of chemicals and plastics and things like that that might get burnt up in the fire, and then those things becoming contaminants that can make their way into our water. So that's become a more local concern. I'll touch on that a little bit at the end. One thing I want to do before diving into those two issues, though, is do what I did last time and try to figure out what issues are important to the people that are here. Because this informs how we do this going forward and what issues we talk about going forward. And it's also really helpful for me as a local environmental scientist who's educating people about local issues to know what people are actually concerned about. That might not always be what's on my radar or what I think is the biggest concern, right? So the questions I would ask you, are there other specific things other than what I've just listed? specific chemicals, specific like types of metals or things like that, or products that you've heard about that you're worried about contaminating groundwater, either for your own health and safety or just in general. Another question I'd ask is, are there other activities that you can think about that you might think could contaminate or affect groundwater, right? So the one way, when I was trying to give you that list, I had trouble organizing it at first. I realized I could list things by what the actual contaminant is or by the activity. And some activities can create a wide variety of different kinds of contaminants, right? So sometimes it's easier to think about pollution not by like what is the actual chemical or something that we're putting into water, but thinking more about like an activity, right? Like people might not know how fracking, for example, for natural gas affects their local groundwater, but they do realize it probably has some effect and they find it concerning, but they don't really know what specific contaminants or things like that might be coming into groundwater due to that activity. And then kind of a more general thing is, are there activities or things like that that you're concerned about that just change groundwater flow and supply? So someone in our last seminar asked about tiling on farms, as I mentioned, which is a process where people can control how water drains off a farm. So you can help essentially catch the water draining on a farm and keep the water there for when it's dry, or then when it's too wet, you can kind of open up the drainage system and let the water sink through and percolate through the soil and leave and drain the soil. So that's not something that's necessarily inherently contaminating the groundwater, but it's changing how it flows and it's affecting the supplies of groundwater locally. So I would open that up to all of you. Feel free to jump in and throw out any ideas or questions you might have. And that also goes for everything that will follow after this when I start diving into the topics that I want to talk about, because this is not meant to be like a one-way lecture. I'm happy to answer questions and stop along the way. So let me go ahead and I'll open up the chat window. People can type things in the chat. Or you can just turn on your mic and shout it out. Anything? Oops, let me go back. I want to jump ahead. Cal just mentioned the quarries. I know that's something that's a concern. I know we have a drainage project here in Sackville, being repurposing an old quarry. I know that's something that's come up a lot as well. A lot of that really depends on what the quarry is in the local area, but something I can tell you that is a major problem throughout Canada, throughout the world, is just mining drainage in general. So whether it be from coal mines, whether it be from a variety of other mines, right? When we carve holes in rock and then allow water to percolate through it, that changes the chemistry of that water and changes the water that goes into our groundwater sources. So that's definitely something that'd be good to talk about in the future. And I can answer some specific questions about that as well. All right, and Mario just asked, groundwater levels have been dropping for several households who use wells, so that much of it is due to the reduction of forest cover on the landscape scale. But you're wondering about insights on that. Okay, that's a great question and a great point. So, and it's one thing that's worth mentioning right off the bat, because the next thing I'm going to talk about is sea level rise and climate change. And it's important to note that those kind of big long-term issues affect our, our aquifers if we like live near a coastline or things like that. But even if you live by a coastline, you have to worry about sea level rise. The daily and seasonal changes in rainfall and the local conditions will still always have a major effect on your local groundwater, right? So it's important to think about scale here, that we're not just talking about big regional global issues, that groundwater can often be a hyper local issue, right? That if you change the landscape cover in a small local area, that's going to affect how water moves across the land. It's going to affect whether or not water is able to sink into the soil and make it into locations that trap groundwater. It's going to also determine whether or not that groundwater is being naturally filtered by processes on the landscape, right? So the reduction in forest cover, that can be tricky. It depends on the area and kind of the slope and the general landscape and the type of soils and aquifers we're talking about. So in the case that Mario brought up with like reducing forest cover, for example, if you clear off the forest on a landscape, you've potentially allowed more water to make it into the water table, to make it down into the groundwater, because now there's not trees holding that are going to absorb that water in their roots and trap it. On the other hand, actually more the bigger issue is that now you don't have these root systems that aerate the ground, and you don't have these trees and all the infrastructure that they make underground essentially to help trap that water as it moves over the landscape. So often what happens when you clear cut a forest or something like that, the soil essentially becomes harder packed and more impermeable, and the water will run across it on the surface into a stream rather than percolating down into the water table, right? A lot of it depends on the local landscape, but that is definitely something of concern. The bottom line is that if you cut down a forest, you are going to change the groundwater situation. You're going to change the chemistry and the flow and the amount of groundwater locally, right? Whether or not that's actually could be causing what's like the drop in a local area, that might be hard to say. A lot of that also depends on, this is another important point for us to think about with groundwater, is that groundwater exists on a different time scale than we do, right? Depending on how deep you're taking it, right? If you're getting groundwater that's really deep, it takes a long time for the water to trickle down from the surface and actually make it into that groundwater. So things that are happening on the surface now aren't necessarily affecting that groundwater in the short term. But if we're talking about really shallow groundwater wells, that's really quick. That's on the same time scale as this, right? So it depends on where you are. It depends on how deep the groundwater essentially is that you're pulling from, or maybe how protected that little pocket of groundwater is from influence from the surface. But that's a great thing to point out. That's something we can definitely talk about more, because it's obviously a huge issue to discuss, and it kind of ties in with the idea of forest fires as well, is how does changing what's on our landscape affect whether or not groundwater is recharging and being refilled. So that's a great thing to note for next time as well. Any other questions or topics that come to mind? All right. Well, quarries, one that have come up again in mining. I could go on forever about mine drainage and things like that. But I definitely like the landscape one with forestry, because again, that's a good tie-in with forest fires. So we can revisit that another one. Okay, let me roll ahead here. So the first thing I was going to talk about, as I mentioned, was sea level rise. And I feel like I'm obliged to say this. I usually kind of avoid saying this when I'm talking about climate change and sea level rise, because I feel like we've moved past the point in history where we need to explain that climate change is actually happening and why it's happening. But that's probably because I work in a biology department at a university, and then I go ahead and look at polls and see the alarming number of people that don't think that climate change is actually happening or don't think that it's caused by humans. So I will say, just for general public awareness, that sea levels are going up. They go up and change on large time scales, you know, with the rise and fall of ice ages and things like that, and 1,000-year time scales. But we have had a very sharp rise in sea level that has happened within the last couple hundred years. And the only thing that can possibly explain that rise is the fact that we are having large amounts of ice melting on our planet. And that is happening because our planet is warmer due to the release of CO2 and methane, things like greenhouse gases that warm our planet. right? There's, yes, the climate changes, sea level changes throughout history, but there is no way we could explain the very rapid current changes that we see other than by adding in a bunch of greenhouse gases into the equation. So the climate crisis and the greenhouse gas crisis, our release of human emissions of greenhouse gases, is what's ultimately causing our current sea level rise, is what's making it rise faster right now. It is not due to natural cycles of ice ages or things like that. So just getting that out of the way. This is something that I showed last time, but just a quick mention, if we're talking about sea level rise and seawater intrusion, it's important to note, just to quickly review what we're actually talking about. So groundwater on the land, beneath the land, at some point is going to run into the ocean, right? If we think about, we have a zone of groundwater, some 10s, 20 meters below or whatever, depending on where it is, on land. If you just cut a cross section of the land, it's not like the dry surface of the land runs underwater, right? It's more like that water table just goes horizontally until it runs into the ocean. But it doesn't stay the same shape as the water table does when we're farther away from the coastline. And that's simply because water can move in both directions. Water wants to push with gravity or away from more where there's more water pressure. So fresh groundwater is going to push towards the ocean, but also the ocean is going to push back and try to push salty water into the ground at the coastline. So now that seawater becomes groundwater. It's just saline groundwater or salty groundwater. And what we actually get, and this is an important point here, because it'll come up again later, is, as many people probably know or recall, fresh water is lighter than salty water. Water becomes more dense as we dissolve salt into it. So fresh water floats on saline or salty water. So what we actually get at coastlines where land meets the sea is a layer of fresh groundwater that sits on top of a wedge of salty groundwater from the ocean. And the water can move back and forth between these zones. So for example, in areas with lots of tides, when the tide comes up, it pushes seawater into that saline groundwater area like you see on this diagram. And then when the tide goes down, some of that water will squish back out into the ocean from that salty water table. And we tend to have this layer that we call an interface, which is where the fresh groundwater from land meets that salty groundwater that's coming from the ocean, right? And this is kind of where all the action is happening in terms of whether or not you're going to get salty water coming into your pipes, depending on where your groundwater is being taken from relative to that interface, right? So the main thing I want you to get from this is that coastlines slice into our water table and then kind of add a little wedge of salty groundwater that usually sits below fresh water. Another important point is that we have different levels of groundwater in the ground. You might hear about people talking about aquifers or confining layers. So we could have groundwater near the surface, and then you could have a layer underground that blocks the movement of water, and then there might be another pocket of groundwater underneath that. That's what we call like an artisanal well. And that's usually kind of the deep groundwater that people draw drinking water from, things like that, like you see in the bottom part of this picture. So wherever we have another slice of groundwater that's isolated, the same process is going to repeat itself. We're going to have a layer of fresh water that's going to be sitting on top, and we're going to have a salty layer that pushes in from the ocean and can circulate around. So I show you this picture. I think I realized I sat on this picture for a long time in the last presentation. It's worth looking at because it kind of explains the whole process, and it also shows you that it's complicated, that there's multiple layers as you go underground where there's going to be fresh water and salt water, and the locations of those are going to change based on how much fresh groundwater is there, based on what the sea level is, based on the tides, on shorter time scales. So it's a very movable system. So again, this is just showing you the same picture in a different way. The main thing to consider is that we're going to have a zone of groundwater near a coastline potentially, where we have pure seawater in the groundwater or some kind of mixture of it, what we call brackish water. So if you just look at this diagram, right, if we were to make a well right there at that last bit of green land before the coastline and go straight down, right, we'd be going into nice fresh groundwater. Maybe it's not that nice because it's coming from the surface, so it's getting any contaminants that are not really being filtered out directly from the surface. And then we'd hit a layer of brackish water. And then we could go through a layer where there's no groundwater, sealing off another water table, and then hit nice fresh groundwater again. So that's the process of seawater intrusion, right? As we have, let me go back, I should explain that again. As we have sea level rise, the simple explanation of seawater intrusion is that that wedge of salty groundwater, that dark blue color you see, is gonna get bigger because there's more pressure coming from the ocean. There's more weight of water pushing on that wedge to force seawater into the ground, right? So that wedge is gonna build and spread and eventually maybe move into a location where we have a well. Another issue that comes with sea level rise in groundwater threats that a lot of people don't often think about is the fact that we have this layer of fresh water sitting on top of seawater, and if the seawater rises, it's going to lift up that fresh water floating on top of it essentially, which can then push whatever contaminants are in that groundwater into your basement or into a well, right? Or it could push the water table into some place that was storing something that is a contaminant that people thought were fine because it was above the groundwater, but now the groundwater has lifted up and rose to meet it. So what you're seeing here on this slide is an animation from the radio station KQED. This is from a story I used in one of my courses talking about how sea level rise is going to affect pollution in coastal cities. And this is actually was a story about San Francisco. So very different environment from ours, but this applies universally, right? If you have some kind of contaminant underground, right, like in a basement, in a storage container underneath some facility, and then the groundwater level is a little bit below that. If sea level rises and lifts up that wedge of salt water underground, it's going to lift up the water table and then push that upwards into wherever that contamination is. So this is a basic problem in some areas where people who live in basement apartments start having flooding of fresh water from the groundwater that they didn't have before. And that's one problem. But then if there is also nasty toxins and contaminants now being mixed into that groundwater that can be coming into basements or wells or things like that, that's a whole other story, right? So the bottom line is fresh water floats on seawater. And if we lift up the fresh water in the sea, we're going to lift up the fresh water underground. We're going to lift up the fresh water beneath us as well. Any questions about that or anything before I move on? That was a little bit of a dive through the Reader's Digest version of some serious hydrology. So feel free to shoot any questions. Okay, well, the thing I wanted to focus more on, aside from that issue that people often don't think about, which is this upward kind of transport of contaminants due to groundwater, is what the reality is around here. What actual threats of groundwater are we talking about that are being posed by sea level rise? So this is just some of the most recent data that we have. This is from this wonderful series of reports that came out last year from this group called the National Collaborating Center for Environmental Health. And this is just a kind of wonderful, helpful, up-to-date overview of what sea level rise looks like across Canada. And what you're seeing here is a color map is showing you centimeters of sea level rise expected in the next 100 years, right? So by the year, sorry, not next 100 years, sorry, by the year 2100. So within the next 80 or so years. You can see that the more purplish colors are the highest amounts of sea level rise. And as is often the case with things that have to do with climate change and the ocean, in our region, the most alarming colors are surrounding Atlantic Canada. As some people might know, where this is also, the oceans near us are also warming at a faster rate than they are around much of the rest of the planet. So we're kind of a climate change hotspot here in Atlantic Canada. And you can see that the projected sea level rise in our region is on the scale of 120 to 180 centimeters, which is quite a bit in the next 70 years. I should note that, you know, if you look at some of the reports I've seen for local municipalities who are trying to figure out how to deal with this, I saw a report that was from PEI that was from 10 years ago or so, about 10, 15 years ago, and they're saying the sea level rise is supposed to be 30 to 50 centimeters. And then there's a little footnote, it's like, but some people say it might be double than that. Well, now we have more accurate predictions and the estimates have gone way up, right? So this is another story with sea level rise, is that generally as our estimates change, they usually change for the worse as we understand more about the processes. Scientists have tended to be pretty conservative in their estimates in the past. So that's the story more broadly, and a lot of you probably know the story more locally. I've seen things like this. Folks like Dave Leesky here at Mount Allison and many other collaborators have done a lot of work trying to educate the public on the risk of sea level rise very locally in our area, like around Sackville and in Amherst and, you know, the Tantramar area. So this is an animation taken from their work and kind of simplified by the CBC, showing what we could expect of flood risk with excessive warming. I should note that we're approaching 1.5 degrees warming, and you can see on this animation that it's going up to 4 degrees warming. So a level of warming that might not happen necessarily in our lifetimes, but would, you know, potentially in our children's lifetimes, our grandchildren. But, you know, we're pushing towards 1.5 degrees warming at an alarming rate, and 2 is possible in our lifetimes. As you can see, even at that level, there's a lot of water pushing its way towards Sackville. For reference, if you're looking at that, we see Sackville on the map. Note right above Sackville, you can see the shape of Silver Lake, kind of help orient you in the area. So we have concerns locally, right in our own community, about where sea level is going to end up as the seas rise, because we live in a very low area. So we should know that. Hopefully everyone's aware of that. The questions that immediately come up when people see an image like that or hear about that locally, we're going to have more sea level rise here in Atlantic Canada than in other locations, is when will this be a problem? Okay, this is like a general issue we have with everything with climate change, right? Like, I know it's a future problem, but like, how much in the future? Is this something I got to plan for next year? Is this something I got to worry about for my grandkids? And the other question that people will often ask is, so what nearby locations and communities will be particularly affected, right? Obviously, not everywhere in the coastline is exactly the same. Not every place is the same elevation. As you've already probably seen from that cross section of seawater intrusion, can be a complicated process. Well, I was trying to find really good estimates and projections of that for this seminar, and they don't exist, which is often what happens when you try to look up answers like this. But what you do find is what the right questions are for you to ask is. So all I can say about that question in particular, is when will this be a problem, is that it's a problem now. There is already evidence of seawater intrusion in coastal groundwater that people want to use in areas like Rishabukto, in Shediac, and places like that. So this process is already occurring as sea level is rising. And it's only going to become more of a problem in the next 100 years. So in terms of you individually, how do you deal with this problem? If you're going to use groundwater near the coast, you should look into what the quality of the groundwater is, right? And how deep the water you're drawing from is. And maybe if there's any evidence, or someone can go do a survey to see how close is that level of salt water to your groundwater that you want to use. In terms of what locations in particular in our area are most at risk, well, it's not surprising, the communities along the coastlines, but there's obviously a lot of coastal communities in New Brunswick. The ones that are most at risk are the ones along the bend of the Northumberland Strait, basically between Rishabukto and Capillet and areas like that, but also in particular the Chignecto Isthmus, right? The stretch of land that connects New Brunswick and Nova Scotia, which you've probably seen a lot of news stories about recently, that there's a big disagreement between the province and the federal government about how to pay for protecting this little strip of land that connects our two provinces around here, and that it's clearly under threat due to rising sea levels. So I don't have great satisfying answers to those basic questions, and that's because the data doesn't exist, that we don't sample enough around here, and then we haven't done enough work around here to be able to give really firm estimates and answer those questions. The locations questions I can be more firm about, right? Like if you live on a coastal community in one of those areas, those are the areas of concern. But I would flip that around and say, what are the questions that you should be asking, right? If you're concerned about this, or if you're concerned about this in your local area. And one that I would suggest, and the questions you can possibly answer on your local level, are what systems control sea level coastal flooding near you? In other words, like if you live by Sackville, we're talking about dikes and things like that. We also have drainage and retention areas. What is, it's not just the fact that you live above the ocean that keeps the ocean out of your front yard. There are systems in your community that are in place to keep the ocean out of your front yard. So it's good to be aware of what those are. How are they being maintained? What is the lifetime of them, right? Another thing to think about is, where are your groundwater resources located? Sorry, let me go back to this. I can't see my other side. And how deep are they? So as you saw from that cross section of groundwater along the coastline, there might be shallow groundwater that's going to be really easy to mix with seawater, and that's going to be the groundwater that, say, when sea level rise goes up, that's the groundwater that would push into your basement or that could contain some contaminants. That's generally not groundwater that we worry about drinking, the shallow groundwater, but it is the groundwater that can affect us during floods. And there also is deep groundwater, right? Which is going to be trapped in deeper layers. It's going to work on a different time scale. So if you're talking about what groundwater resources you're concerned about, it's important to know which ones we're talking about, right? It's important to know where they are, like near you, where on a map, but also how deep they are, right? Because those things are, those different levels of groundwater with depth are going to behave differently. Another basic question is trying to figure out, obviously a lot of people wouldn't have the ability to do this themselves, but it's not very complicated science. Basically with just something that measures saltiness and drilling some groundwater wells, people can figure out where that interface is, where that seawater groundwater interface is near you. So again, just to jump back to that picture, right? That little area where you see saltwater interfaces, understanding where that is on a particular area in the coast around here is really important, because like that's the front lines of this fight between the ocean and the groundwater. And I should note, like I said here in that slide, oops, this can vary a lot along coastline. So when I've looked at locations of this around Northumberland Strait, there might be some places where that line, like where you have to go to get to it at a depth where people usually pull groundwater from, it might be 50 meters from the coastline. And then you go down the road a little bit and it might be 200 meters away from the coastline. And then farther down, a couple kilometers away, it's 400 meters, right? The point is that where that line is, you're only looking at it in 2D. If we look at it in 3 dimensions, where that mixture of seawater and groundwater is underground, it varies a lot along the coastline. So understanding where that is near you is going to tell you basically how close are you to the front lines of this fight between the ocean and groundwater. So these are questions that can be answered locally, that if you're concerned about this in your community or more broadly in the area, these are the kind of questions to ask local authorities, to see if you can have evaluated on your own, to discuss with local environmental groups. These are the things that are going to directly affect the outcomes for you. I'm running low on time to talk about wildfire, so I want to stop and ask questions real quick, but I can get into that a little bit. And I plan on touching on it more next time. But before I dive in, I just want to make sure if there's any questions on what I was just talking about before I move on, or anything you'd like me to clarify. Kat, if you have any suggestions. Anything? Okay. Well, in a little bit of time I have left, I'll go ahead and I'll say a little bit about the forest fire risk as well. So let me go ahead and pull that back up. So a little bit of time we have left, I'll just mention this. So another issue locally that's worth getting into is the threat of wildfires. So let me actually need to go ahead and play my slideshow here. Sorry. Jump to the right slide. Okay. So this is a picture from Kent County nearby. I think sometimes we think about the wildfires as a pretty far away problem if we live here close to the coastline in Tantramar, but a lot of the ones in New Brunswick weren't that far away, right? And they can cause very significant destruction even when they're happening on the small scale, right? Of clearing these forest areas. So, and like I mentioned before, we have water making it into our aquifers, into groundwater, by seeping through the land through porous layers, right? What we call infiltration. And you can see just in a picture like this, if you have a landscape that was covered with open, aerated, loamy soil and lots of plants and trees, and now it's this ashy, flat, barren hellscape, that process of how groundwater recharges and how groundwater can go through is going to be affected. Just kind of, you can assume that just on face value. And this is a really helpful diagram that I found from Inside Climate News that can help sum up visually some of the things that we can talk about that happens because of this. So when we have a massive wildfire and the removal of vegetation on the landscape, right, we're going to change how water runs off the land. We're also going to change how soil gets eroded, right? We're going to have an increased risk of mudslides and more amounts of soil, along with all the ash and debris that is there from the forest fire, being carried along the surface and washed off and entering into streams. So without even talking about like industrial contaminants, just the fact that we'd have more mud and ash and debris going into streams is something that can have a really negative effect on life in the area. These things are also going to carry with them more nutrients that can act as fertilizer in the water, that can cause blooms of microbes that are harmful, or as those microbes and other things that are in the water consume oxygen, that's going to end up with lower amounts of oxygen in the waters affected by the fire that can eventually suffocate seafood and fish and other marine animals. But then we also have the concerns of toxic materials coming from residences and things like that. The huge variety of things that many people are concerned about, of toxins that are in our daily life, are going to be ground up by the fire and then able to leach into water. And also they're going to be transformed by the fire, because we might look at certain concerns of toxins in our household, but we don't usually think about how toxic are they after they've burned, right? So all of these, so when we talk about is wildfire in our local area something that's going to have an effect on groundwater, it certainly is. And the very basic level, it's going to affect how water can actually recharge and go into the aquifer and go into the water table. But what toxins it carries with it depends on what got burned, right? It depends on if we're talking about industrial areas or residential areas. But I should note that just the ash and burnt material from wood itself can be toxic, as many of us should know, right? Inhaling too much wood smoke is not good. There are things like polyaromatic hydrocarbons, or PAHs, that are carcinogens that come out from ash and charred wood and can then be carried into water and then eventually into groundwater through these same processes that we're describing here. So we're short on time, it looks like. So that's a little bit of the story about the wildfires, but I don't want to keep anybody late. So there's definitely more to talk about there in the future. Yeah, so I'll leave it there.